Good morning, all. Today we will see the design principles for wireless sensor networks. So, in taking the design principles, so first we need to organize the network in a distributed fashion. That is, it should not be a centralized one. The network should not be a centralized one. So such an actually centralized entity could, for example, control medium access or make routing decisions similar to the task performed by a base station in cellular mobile networks. So what happens is centralized network if you design, then if the failure of any one entity will entirely shut down the network, which should not be our motive. So if any one part is not like under failure, then the other parts which is not in relation with this failed part should keep working. So in that way we should see to it that the design must be taken. The disadvantages of such a centralized approach are obvious, as is introduces exposed points of failure and is difficult to implement in a radio network where participants only have a limited communication range. So, uh, actually, what it means is even for your mobile network or any other network, when we say wireless sensor network, the communication range comes as of utmost priority when we design, because the communication power from the transmitter is like it is very, it should be very high. So if I do everything as centralized, then the range, working range becomes minimum. So we don't go for the centralized uh, network. It cooperatively organize the network using distributed algorithms and protocols. So that is called as self-organization. In network processing, actually, what is in network processing? The nodes in the network are not only passing on packets or executing application programs, they are also actively involved in taking decisions. So this is actually we consider it as in network processing. Now next type could be aggregation. So like what are we discussing now? The design aspects of wireless sensor network. So second type is aggregation we can do. So that is from many nodes you are expecting a similar task. From many nodes you are expecting a similar task. Then actually, instead of taking each and every output of each and every node, I can aggregate those data and consolidate it, and I can take that. So suppose a sync is interested in obtaining periodic measurements from all sensors, but it is only to check whether the average value has changed or whether the difference between minimum and maximum value is too big. Then actually I can go for aggregation. Where, okay, where can I go? Where actually the individual data does not make much difference, then I can go for aggregation. In such a case, it is evidently not necessary to transport all readings from all sensors to the sync, but it suffices to send the average or the minimum and maximum value. So aggregation stems from the fact that in nodes, intermediate between sources and sinks, information is aggregated into a condensed form. This is what I said. Aggregation means, okay. See, aggregation can be take, if at all you have to take an average, okay, then take all the values, then add and do the average, or sometimes okay condensed form. So like many nodes are sending a similar almost similar type of data, then actually you can ignore some of them. You can condense the data and you can further transmit that. Aggregation condenses and sacrifices information about the measured values in order not to have to transmit all bits. Of data from all sources to the sink. So now here in the pic, if you see, it is 13 packets from here. So from this node, actually one packet is coming here from one. Actually here it aggregates, okay, and it becomes three nodes, three data packets. Okay, from here actually it is coming one. From here it is coming one. So totally we are having six. So this six goes to the sink. Okay, it is aggregated. Now that six aggregated, see here, one, all one, in this way it is going. So this is actually 13 packets have become six packets in this. Now next is data centricity. So data centricity is, see, actually I'm not bothered from which node I am getting the data, but I am interested in the data alone. That such designing is called as data centricity. Sometimes that is that, I mean, you need to design in a data centricity form, because many nodes will be there, many sensors will be there in the network. Okay, I am not interested to know from which node I got it, but whether that event has occurred, whether did I get any data, that is important for me. Okay, lightning or thunder, okay, rain, anything for that matter. Okay, many sensors we would have deployed. In that case, which node has given me this, that is not important, because I have put in a nearby areas. Okay, whether that event has occurred, that is important, the data is important. So that such designing is called as data centricity. In a wireless sensor network, the interest of an application is not so much in the identity of a in the identity of a particular sensor node. It is much rather in the actual information reported about the physical environment. Since there will be many redundant nodes, multiple nodes may send the same information. Okay, in this context, data is important, not the sender. Okay, so data centric networking it is called as. Okay, presence of an elephant in the last class example, if you see, okay, is important than, okay, which node, because the nodes were kept very nearby. So which node has sent that is doesn't matter much. Then coming to another type of design, that is publish and subscribe. So any node interested in a given kind of data can subscribe to it, and any node can publish data along with information about its kind as well. So this is one type. So any node interested can subscribe or can ask for the data, and any node which is having that data can publish the data. Okay, so this is also possible in the design of the WSN. So in the elephant example, sync nodes subscribing to the event elephant detected. Any node that is detecting the elephant can publish this event. See, actually, see, an elephant coming to one area is detected, for example, is detected by 2 to 3 nodes. I have deployed around 10 to 12 nodes. In that 2 to 3 nodes have identified, detected it, the elephant. When the sync node is requesting, okay, for any detection of the elephant, then among those 2 to 3 nodes, any node can publish. Okay, there are hurdles. What if 3 nodes also publish simultaneously? Is it not redundant data? Yes, it is redundant data, and actually care has to be taken to synchronize among those three. Okay, but those three can uh, publish the data. elephant detected. Next one is exploit location information. Okay, so based on this feature, the design of the WSN can be done. Since the location of an event is a crucial information for many applications, there have to be mechanisms that determine the location of sensor node. So having the sensor node location is important here. So this is another type, not like unlike the previous one. Once such information is available, it can simplify the design and operation of communication protocols and can improve their energy efficiency considerably. Other nodes we can switch off. Okay, this is exploiting the activity pattern. Okay, when there are rare events, data rate averaged over a long time can be very small. Okay, so when there are more events, it can be detected by a larger number of sensors, causing a well known event shower effect. So, this is actually considering this, you are designing, considering the activity pattern. Whether you need to have an idea whether this activity is continuously recurring or it is like very rarely occurring, that you need to know. Based on that, actually, you can deploy the uh, network. The protocol design should be able to handle such bursts of traffic by being able to switch between modes of quiescence and uh, high activity. Now, exploit heterogeneity. So, heterogeneity means uh, till now we were discussing about many nodes. When I say many nodes, you used to think that these nodes all are okay, these sensors all are of similar kind. Okay, but here actually we can design a wireless sensor network with different nodes, different sensors. Okay, so that is why it becomes heterogeneity by construction. That is, some nodes have larger batteries, okay, or farther reaching communication devices, maybe a high powered antennas or something like that, or more processing power. So every sensor need not have that. It depends on the task what you are doing. So in this advantage is by an asymmetric assignment of task, giving nodes with more resources or more capabilities, the more demanding task. So actually, what can I do? The resource, whatever I am having, power. Okay, with resource, when I say, it means the power. The power, whatever I'm having, I can give it more to the more demanding task. Okay, I can give less to the less demanding task. So in that way, uh, I can optimize my power level. But the disadvantage is these asymmetric task assignments cannot usually be static. It is like dynamic. So have to be re-evaluated as time passes and the node or network state evolves. Reassigning the task is a burden. So once you are doing, okay, for some time that task will be performed. The task will be performed. Or after that, okay, so either you need to change the uh, hardware hardware requirements for it, or okay, you have to, for the same hardware whatever you are having, you have to assign some new task for it, so that becomes a burden. Okay, next, coming to gateway concepts for wireless sensor network. Gateways, okay, we have learned they are necessary to the internet for remote access, okay, or from the wireless sensor network. For ad hoc networks, okay, what we have in the wireless sensor network, so gateways are required. The additional complications due to mobility, okay, change route to the gateway, use different gateway, So these are the additional complications, okay, what we may get it. For wireless sensor network, additionally bridge the gap between different interaction, okay, semantics in the gateway data, or is it address centric, okay. So gateway support is check out here. These are the wireless sensor networks. Okay. Then from this is the gateway node. From here it is connected to the internet. From internet, okay, it can go to the remote users, different remote users. So gateway node is there. From the gateway node, it's only okay. It is getting connected to the internet, not from any other nodes. The user equipped with the PDA moving in the coverage area of the network, or a remote user trying to interact with the sensor network via the internet, okay. So for all these gateways, okay, becomes a big help. Okay, wireless sensor network first of all has to be able to exchange data with such a mobile device or with some sort of gateway which provides the physical connection to the internet. The gateway either should have wireless technology to connect to internet, or protocols inside the wireless sensor network to connect to the internet, okay. So these either of these should be there, okay. Either gateway should have the technology, or the internet as well as your WSN should share the protocol, okay, which tells what the gateway should do. Okay. Now the wireless sensor network to the this thing internet communication, that we will do it in the next class. Okay. Thank you.